All right, so for chapter 2, we are doing a lot of the same stuff we did in chapter 1, but now we're doing it with inequality signs rather than equal signs. Okay, so yes, it's a little bit new, a new part of it with the inequality sign. But the majority of it is stuff that we already know how to do now. Okay, so we're going to solve this the same way that we did in chapter 1. We're not even solving equations today. All we're doing is talking about inequalities, what they are, what they mean, what they look like, all that kind of stuff. Okay? So what I want you to do with the person next to you is I want you to tell them what these symbols represent.
Oh, yeah. And that one is.
All right, here we go. So these are inequality symbols. I know what they mean. We need to know how to say them correctly. Okay. We need to not the alligator eats the bigger side. You know, we need to know actual mathematical stuff now. Right. All right, raise your hand. Tell me how would we say this one correctly here, Micah?
Less than.
This is not less than. Silas, greater than. We read it left to right. And so the bigger side is over here. So this is the bigger number. So this would be greater than this. Okay, so this is greater than. We're going to write down some notes on each one of these. Okay. So let's make sure we got it in our notes. So you're going to see greater than. You might see more than as well. Right, depending on where you see it, you might see that phrase as well. The reason why we're going to write down some of these phrases is because you're going to see today, they're going to write it out as a sentence, and you're going to have to convert it into an inequality. Right? They're going to say a number is greater than 7, and you need to be able to change that into an inequality. Okay, so we got to know those key phrases. We got greater than, we got more than. Okay, what's our next one here? What's our next one? Real? Less than. Less than. Or another phrase be here, Michelle? We could say smaller than. You might see the phrase fewer than. All means the same thing. Okay, raise your hand about our next one. Here. Our next one here. Cody.
Greater than or equal to.
There you go. Looks like it's called greater. Greater than or equal to. Remember, you got that line underneath. That line underneath is like half the equal sign. So you got greater than or equal to, one or the other. Okay, and we'll talk about that a little bit. We're just getting phrases down right now. We have another phrase that might work for that. Yeah. At least. So that is at least. Good. And the other one that we'll throw up there is no lower than. Or sorry, no less than. Sorry, no less than. Which can be confusing because we have less than and then we have no less than. It's a slight change, right? But if it's saying it's no less than this, if we have x and 4, we're saying x is no less than 4, means it can't be smaller than 4. Right? It's at least 4. It's 4 or bigger, greater than or equal to 4, right? All of those mean the same thing. So we just gotta be able to pick those out. We see them in a word problem or something like that. All right, using that as our guide, what do we say for the next ones here, Tim? Less than or equal to. Okay, what else could we say here? Two,
At most.
at most.
That's a good one.
Most. And
No more than.
no more than. Thank you to those of you that are writing this down. Finding it important. That's good. I'm taking the time to write all this stuff on the board. You should be writing it down. What about that last symbol here? What's that last symbol?
Not equal to.
Not equal to. Anytime you see the line crossing through a symbol, that just means it's not that. It's not equal.
I'm not equal.
Not equal to whatever. Okay. Good deal. So we're pretty good at these typically. The ones that tend to trip us up on word problems would be these right here. Okay, the at least, the at most, no less than, the no more than. So those are going to be ones that you want to study, right? So when we see at least, you understand what that means. You understand what symbol, not necessarily just memorizing the symbol that goes with it, although that will help. Understanding why it's that symbol is even better. So let's take at most, right? We got x is less than or equal to 10. We could say x is at most 10. Think about what that actually means. At most 10. The most it could be is 10. All right. The biggest it could be is 10, or it could be anything smaller than that. That is the symbol for at most. Because it could be that or anything smaller than that. So again, these symbols going to be important, these words going to be important so that we can kind of exchange words for symbols here. Yeah.
So for those two, like for the x is greater than or equal to 4, if you want to change the 4 to 3 and then just take out the line, would it just mean the same thing?
No. The question that James has is, are these the same thing? No, they're not. All right, why not?
So that would go all the way up to 4 and that one then only go up to 2.
Okay. So
Wait, no.
I think what you're trying to, I think what you meant was this. Right?
Like,
I think this is what you were trying to get at. Okay. Where x is hold on. Hold on. No, I think you're right. I think you're right that time. It's early in the morning. I'm getting there.
Yeah.
Yeah, so this, right? You're saying x has to be greater than 3. Isn't that the same thing as saying greater than or equal to 4? The answer is no, because what about 3.5? Right? So we can't forget about all the decimals that are in between, which is why we have that or equal to. Because if we have x is greater than or equal to 4, that means it can be 4 or anything bigger than that, right? Anything that direction. If we just say x is greater than 4, let's say, it could still be 4.1, 4.01, 4.003, right? So there's a lot of other numbers in there. So we just got to be careful with that idea because we got those decimals too. Yeah. Go ahead.
That's what I was gonna say.
3.9 repeating is the same thing as 4. Yeah, it's the same thing as 4. Yeah, but we're like years away from talking about why that's the same thing. All right. Anyway, let's move on. Yeah, Aiden. Why?
1/3 is If 99.99 repeated in a fraction, it would probably be 3/3. 3/3 is equal to 1/3.
Yeah.
Wow.
That was in, gosh, I don't even remember what class it was. It was in college though, where I had to prove that. And it was the same thing, right? Why is 0.9 repeated equal 1? Because 1/3 is 0.3 repeated. You had 1/3, 1/3, 1/3. You have 0.9 repeated, which is 1. Yeah, that's great. Good thinking right there. Nice.
How is 0.3 repeated 1?
What's 1/3 as a decimal?
0.3.
0.3 repeated, right?
Yep.
Okay, so I add another one of those, and another one of those, right? So now I've got 0.9 forever.
Yep.
Well, we know 1/3 plus 1/3 plus 1/3 is 3/3, which is 1.
That makes no sense. But how is it 1 if it doesn't say it's 1? Yeah,
It means the same thing.
no, because
We just showed that.
no. Because what if there be a at the end of that there be like 3, 3, 3, 4?
Nope, because it said it goes forever. It goes forever.
So technically it does.
Yeah, it does.
Because
It does. Just because your calculator says it stops doesn't mean it does. Keep going forever. This is why I did it in college and not 7th grade, right? All right. Moving on. Moving on. Moving on. Moving on. What we have to be able to do with that? What we have to be able to do with that is this. We have to take these and change them into mathematical sentences. Okay, so I want you to go ahead with somebody next to you. I want you to write down what these would look like with an inequality sign. Okay, changing this into some algebra here. Go ahead, guys, down. Look at all three of them. All three of them. All three of them. All right. So it is a flex day. We are running low on time here. And we're gonna get some time to work on homework. So we got to move a little bit faster. A number W minus 3.5. So a number W means they just tell us which variable we're using. Minus 3.5 is less than or equal to -2. There you go. And we're not even solving today, right? We're just writing out. We'll start solving tomorrow. Yes, that's the next thing we gotta talk about. The other thing we gotta talk about. 3 is less than a number n plus 3. So 3 is less than a number n plus 5. 0 is just a number. Feel free to use 0 when it says 0. Is greater than or equal to twice a number x plus 1. How would we represent that? How would we represent that? Drew? Yeah, it could be a little confusing here, but they mean 2x plus 1. If they wanted that other way, that brings up a good point. If they wanted this, they would have said twice the sum of a number x plus 1, right? that would signify that we wanted that x plus 1 together. So that would be it. All right, let's move on. So they're going to ask us if something is a solution or not. Okay, so we're not necessarily solving. We're going to be plugging a number in and saying, does it work? Does it not work? So if we take a -4, we plug it in. What is -4 plus 8? 4. Is 4 less than -3? No, so not a solution. Right? We take a -4, we plug it in. What is a negative times a negative? Positive. So even if we don't know the actual number, we know it's going to be a positive something. Is that going to be greater than -21? Yes, great. So our answer is yes. Those are yes or no questions. Right? Now, ones to be careful of is when the two sides equal each other. Right? Let's say we plug something in and we end up with 10 is greater than 10. Is it a solution?
No.
No. What if we had that?
Yes.
Yes. So just be careful of the symbol, especially when the two sides are equal. Okay, be careful of the symbol. The other one that we tend to mess up, guys, is when we have negatives. Okay, when we have negatives, is that true or not true?
True.
Hey, so we got to think of our number line, right? Our number line, zeros here, right? We're looking like this. So -4 is greater. -4 is greater than -8. It's be down here. So this is true. Okay, it's closer to 0. The negatives that are closer to 0 are the bigger numbers. Okay, so that is a good statement there. Okay. Other thing that we're gonna do is we actually do have to graph it. So if I wanted to graph, let's say x is greater than 4. X is greater than 4. Give me a number, raise your hand and give me a number that would be a solution to this. Give me a number that works here. Michelle?
4.9 repeating.
4.9 repeated. Okay. Dave?
4.0000001.
Okay. Good. Thank you.
6.175217.
Perfect. Thank you.
Wait. Keep going on by like 7.1.
You could, right? Something over there could work. Okay. So we know all of these are going to work, right? All of these are going to work. Is the number 4 a solution? No. Raise your hand and tell me, what are we going to do to represent the fact that number 4 is not a solution, but everything else above it is? How do we represent that, Tyler? An open circle. An open circle. That open circle tells us that that number is not a solution. That's what that open circle tells us. That open circle tells us 4 is not a solution, but everything greater than that is. So the arrow tells us that it is a solution above that. Okay, that open circle tells us that is not a solution. We need that there because we can't just start our arrow at 4.000 whatever, because we can always get closer to 4. There's an infinite number of numbers in there. So we put that circle saying, all right, 4 isn't, but everything bigger than that. Huh? Okay. All right, so we got that. So anytime we have greater than or less than, these are going to be open circles. Greater tn or less than are the open circles, because that number is not a solution. Once we throw in the or equal to, how do we now represent the or equal to? Closer, right? Because now we see that closed circle. That closed circle tells us 4 is a solution, along with everything greater than. So greater than or equal to, less than or equal to, those are closed circles. Okay, so I am going to ask that you write these on your homework as well as on the computer. Okay, because you're going to have to graph them. Now, when I want you to graph them on your paper or on a quiz or on a test. I'm not gonna have you write out, I don't want you to write 10 numbers down. Okay, it's a waste of time. So what I want you to do, let's say that I have x is less than -2. Whatever that number is, I want that in the middle, and I want one number on either side. I just want to make sure you know what order the numbers are supposed to go. Tell the person next to you what number is supposed to go here, what number is supposed to go here. Okay, well, it's gonna go right here on the left side. -3, and then, okay, open or close circle? Open circle, arrow to the left or arrow to the right? Arrow to the left. Remember, guys, the arrow represents your variable. The arrow represents what x could be. X is smaller than -2. So my arrow is smaller than -2. Please do not get in the habit of just facing the arrow the way of the symbol. Do not get into that habit. Because when it flips around, it's going to be wrong. Okay? If you go to graph this, x is bigger than 4. I go to graph it, x is bigger than 4. Okay? So instead of using the shortcut of just face it the way of the symbol, you need to understand what the symbol means and that the arrow represents the variable. That's where we fall into trouble, and I see it every single year. Okay? We cannot fall into that. So please be careful of that tonight. So you're going to see those. They are going to also give you this and ask you to come up with the inequality. Okay, we should be able to do that. Any questions about it? Okay. So that is